So what we're going to do here, given the conjugate roots, or the conjugate pairs theorem, is we're going to come up with the roots. And based on what we just said here, all that happens is, if we have 4i as a root, then we're going to have negative 4i as a root. If we have the square root of something, in this case the square root of 7, then we're going to have its opposite, which is negative the square root of 7. Notice on this problem that we have degree 4. How many answers do we have? 1, 2, 3, 4. If we look at the second problem, there's a degree of 3. How many answers or roots or x-intercepts do you think we'll have? 3. If the degree is 3, there's going to be 3 roots. One of them that we're given is I radical 11. If we have an I, or we have a radical, what do we also have in terms of a root? We're going to have the opposite of that. Now, the thing not to change is the 6. I'm colored, but the only thing that we change is if we have a square root of something, then we have the plus and minus. If we have an imaginary, then we have a plus and minus. The regular numbers that we're used to working with in our polynomials, we don't have to change any signs. So when we look at number 3 here, it says degree 2. So how many roots do we have? We have 2 roots. Our root that we're given is 6 plus 3i. So what does that mean we also have? And we also have the 6 minus. And when we look over here at number 4, degree 4, how many roots do we have then? 4 roots. So we have 1 plus I, and therefore, what do we also have? 1 minus I. We change one sign in the binomial. We have 2 minus the square root of 3. What do we also have in terms of roots? So it would be 2 plus the square root of 3. We change one sign in the binomial. 1, 2, 3, 4 roots. Do we have the basics? You got to understand that. Terrible English that's going to be on a video before we do the next. So when we look at problem number 5, here's one of my flaws. So I'm going to add in one thing, but it says write a polynomial of least degree with integer coefficients. So that means we don't want to have fractions in our problem that have the given zeros. And what I wish I would have done is what I did up here in these previous problems is put, let's speed that down a little bit again. I'm going to put degree 2. So degree 2 then means, therefore, that we are going to be looking for 2 roots. 6 plus 3i is one of those roots. What would be our other root? 6 minus 3. Now, what I would like to teach you here is a shortcut process. And it's not going to be that short. But here's how it works. When we started our polynomial, what we did is we said, well, x equals our root. So it's x equals 6 plus or minus 3i. Well, what we're going to do is we're going to isolate the I. we need to deal with the plus or minus part of this problem. So we're going to subtract 6 from both sides. We end up with x minus 6 equals plus or minus 3i. What we're trying to do is we're trying to write an equation in standard form that allows us to work with these values here, with these two roots that we're given. So the next step here is going to be that we are going to square both sides. So this means on the left here that this is x minus 6 times x minus 6. But over here on the right side, we need to figure out the plus or minus. But if we square 3, positive 3, say, what do we get? 3 times 3 is 9. If we square negative 3, what do we get? We still get 9. It doesn't matter that it's plus and minus here. When we square this, it's going to turn into positive. And squared means times itself. So now, we have this polynomial in a format that we can get it to standard form. We are going to multiply these two together with FOIL. X squared minus 6x minus 6x plus 36. And 3i times 3i is 9i squared. 3 times 3 is 9. I times I is I squared. If we combine like terms over here on the left side, we end up with x squared minus 12x plus 36. What does I squared equal? Negative 1. And the more you say that out loud, the better you're going to remember it. So we get x squared minus 12x plus 36 equals negative 9 when we multiply those two together. And now, when we move our 9, our negative 9, over to the other side, we will have our polynomial in standard form. X squared minus 12x plus 45 equals 0, or equals f of x. Not picky about the equal 0. The answer to this problem is 6 plus 3i and 6 minus 3i. Why do we square? Like the third step. Problem number 6. Again, my flaw. Well, I'm not going to go away right now. My flaw is that I did not put the degree on these problems, and I wish that I would have put the degree on these problems. So what I'm going to say is that the degree of our polynomial that we're going to end up with is going to be 4. So if our degree is 4, how many roots should we be working with? We should be working with 4. We're going to have 4 roots, and roots are also called x-intercepts or zeros of the function. So what we have is we have 1 plus I. So what is our counterpart to that? 1 minus I. We have 2 minus radical 3, and what is their counterpart to that? 2 plus. We have to have the conjugate, which is we change one sign in the binomial. So now, go as far left on this as you can. I think that we can fit it in, but what we're going to do is we're going to set this up as x equals 1 plus or minus I. 1 plus also going to set it up as the x equals 2 plus or minus square root of 3. We're going to have to go through the shortcut, I say in quotation marks, because it's not going to be short. But we're going to have to put this in this format so that we can multiply our two together and come up with our 4th degree polynomial. So what am I talking about? Well, what I'm talking about here is the first thing is we are going to isolate the plus or minus part of this problem. We're going to subtract 1 from both sides. When we get x minus 1 equals plus or minus 5. We want to deal with that plus or minus, and the way that we're going to deal with that plus or minus is that we are going to square both sides. So we get x minus 1 times x minus 1. But it doesn't matter whether we square a positive value or we square a negative value. Positive times positive is positive. Negative times negative is still positive. Over here, this just means I times I. And now we're going to FOIL. X squared minus 1x minus 1x plus 1. When we multiply those two binomials together, on the other side we have I times I, which is I squared. If we combine like terms, we have x squared minus 2x plus 1. And what does I squared equal? -1. I'm back to haunt us. So I don't really need parentheses around that, but I'm going to put the -1 there. And then, to finish this part, we're going to add 1 to both sides. And we get x squared minus 2x plus 2. Don't put the equal 0. Because we're going to take that trinomial and we're going to multiply it by the answer that we get from dealing with our other two roots here. So try to go up and write it beside there if you have enough space. And what we're going to do is we're going to subtract 2 from both sides. We're going to isolate the plus or minus. It's going to be x minus 2 equals plus or minus the square root of 3. To deal with the plus or minus, we are going to square both sides. And when we do, that means that this is going to be x minus 2 times x minus 2. And over here, positive times positive is positive, negative times negative is positive. This is radical 3 times radical 3. We're going to multiply those two parentheses together. We end up with x squared minus 2x minus 2x plus 4. And what's the square root of 3 times the square root of 3? It's just 3, right? Square rooting and squaring cancel each other out. You might put the square root of 9, but what's the square root of 9? It's still 3. If we combine like terms, we have x squared minus 4x plus 4 equals 3. And now for this part of the polynomial, when we subtract 1 from both sides, how about we subtract 3 from both sides? We subtract 3 from both sides. We get x squared minus 4x plus 1. So now we have our two polynomials. And we're going to multiply these together to get our final answer of degree 4. And it's a distributive property process. And I'm not going to put all the arrows in, so to speak. But we're going to take x squared and we're going to distribute it over all of our values in our blue polynomial. We're going to take negative 2x and we're going to distribute it over here. We're going to take the 2 and we're going to distribute over here. And I'm going to color code that a little bit. I don't think that you need to on your paper, but I'm going to color code it just to keep track of everything. So the first time through, we're going to take x squared and we're going to multiply it by x squared, which is x to the 4. X squared times negative 4x is negative 4x cubed. X squared times 1 is x squared. Negative 2x. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 4x is positive 8x squared. Negative 2x times 1 is negative 2x. And then 2 times x squared is 2x squared. 2 times negative 4x is negative 8x. 2 times 1 is 2. And when we combine our terms, we will end up with our 4th degree polynomial that has our given roots. So we've got x to the 4th minus 4x cubed minus 2x cubed is minus 6x cubed. Don't forget that there's a 1 in front of that x squared, but 1x squared plus 8x squared is plus 9x squared. And what did I forget? I forgot my 2x squared, so let's try that again. So we have 1x squared plus 8x squared is 9x squared, plus 2 is 11x squared. Then we have negative 2x minus 8x, which is negative 10x, and then plus 2. So to finish here, this polynomial, by the way, is going to be a 5th degree. Let's try that again. It's a 5th degree. So when we look at this, we have negative I radical 7. So what do we also have? Positive I radical 7. There's the conjugate of negative I radical 7. We have 2 plus the square root of 5. So what do we also have? 2 minus the square root of 5. Now notice, we are not going to do anything to 0. In fact, that's the last value that I will deal with in a few minutes. Let's get these other two in the same format, and then we'll multiply them all together. This is the shortcut version, even though it's not going to seem like a shortcut. It is the shortcut version. So when we start, we get x equals plus or minus I radical 7. On this problem, the plus or minus part is already isolated. It is by itself. So we can square both sides at this point now. So it's x squared equals, well, this turns out to be I radical 7 times I radical 7. So when we simplify this, when we multiply these two together, we end up with I times I, which is I squared, and radical 7 times radical 7, or the square root of 7 times the square root of 7. Two of the same value to take out one. Square root of 7 times square root of 7 is 7. So when we go to finish this part of our polynomial, we end up with x squared equals, well, what does negative, darn it, what does I squared equal? Negative 1. I pretty much gave it away, but I know some of you knew that. And then we've got the 7. So this is x squared equals negative 7. And finally, let's move the 7 over to the other side. Don't put a 0 in. We have x squared plus 7. So now, let's take our x equals 2 plus or minus the square root of 5. And now we're really going to have to isolate. We were lucky with our blue part of the problem because it was already isolated for us. But here we're going to have to subtract 2 from both sides. So we have x minus 2 equals plus or minus the square root of 5. We're always trying to isolate the plus or minus part of it. And we are going to square both sides. So this means x minus 2 times x minus 2. Over here on the right side, it's the square root of 5 times the square root of 5. It doesn't matter whether it's plus or minus. Positive times positive is positive. Negative times negative is still positive. And now we're going to FOIL. We're going to multiply those two parentheses together. X squared minus 2x minus 2x plus 4. And square root of 5 times square root of 5 is 5. We combine like terms. Get x squared minus 4x plus 4 equals 5. And then we need to subtract 5 from both sides. So we have x squared minus 4x minus 1. So right now, just to line it up a little bit better, we have x squared minus 4x minus 1 along with our x squared plus 7. But that is taking into account the negative I radical 7 and its counterpart, 2 plus square root of 5 and its counterpart. It's not taking into account of the 0. So I can't go horizontally on here, but what we would have written earlier is we would have said, well, x equals 0. And then we would have subtracted 0 from both sides. But do we really need to write down 0? No. We just need to write down x. And for simplistic purposes, let's write x here. And now, as we multiply these out, we will be able to come up with our 5th degree polynomial. And when we start, let's just multiply these two together, get an answer, and then multiply it by our green. X times x squared is x cubed. X times 7 is 7x. multiply here by the green. X squared minus 4x minus 1. And it's a distributive property process. We're going to multiply x cubed times x squared. X to the fifth. Remember, when we multiply, we add the exponents. X cubed times negative 4x is negative 4x to the fourth. X cubed times negative 1 is negative x cubed. Then we're going to take 7x. 7x times x squared is 7x cubed. 7x times negative 4x is negative 28x squared. And 7x times negative 1 is negative 7x. And on this problem, we don't have very many like terms. We have x to the fifth. We have minus 4x to the fourth. In fact, the only like terms that I see are the x cubed. Negative 1x cubed plus 7x cubed is 6x cubed. Minus 28x squared minus 7x.